Okay, here we are with problem 1.14. They want us to identify all non-bonding lone pairs of electrons in the following molecules and tell what geometry you'd expect for each of the indicated atoms. Okay, so let's go ahead and start off with A. This guy here is going to really look like this guy right here, A. He's probably going to look more like this because remember, oxygen has two lone pairs above it, and then it's going to branch down like that sort of thing. And the reason why it's pushed down like this in a bent type of shape is because of these electron pairs up here, these lone pairs. They put pressure on this entire compound, and in effect, what happens is you get this bent shape. Okay, so that's what it's going to look like. Now, they want us to go ahead and identify the non-bonding lone pairs, which is easy enough. You got these guys and these guys. That's two non-bonding lone pairs, and that's pretty much it. The geometry, okay, let's go ahead and do that right now. This would be sp3. And if you were to do it in the format where you go ahead and write it out like this, okay, X, okay, A is the central atom, X are the atoms around the central atom, and the E stands for the electrons that are lone pairs. So you could do it this way as well. And what you'd have here is A, X, and on the right side of the X, you would have 2, because you've got this guy and this guy, and then this E would read like this, 2 as well, because you've got two lone pairs. And it's the same thing. 2 and 2 is 4, which is sp3. Okay, so that's pretty easy. Let's go ahead and do B. B is going to look something like this most likely. You've got your nitrogen, and you've got these guys like this. H3C, H3C, and H3C. Okay, and of course, if you're trying to do this with draw it with shapes and what have you, it would be obviously a little bit different. Okay, we could do that in a second too, I guess. But anyways, finishing this up, you've got your lone pair up here, 2 electrons, and that's why you've got this sort of bent shape. Again, this is putting pressure on this, and as a result, what you have here is sp3 again. Okay, 1, 2, 3, and a lone pair makes 4, sp3. Okay, and if you want to go ahead and draw it so that it's 3-dimensional, you could make this guy coming out, the one in the middle. Okay, so it looks something like that. And then these two guys, well, this guy would be on the plane, on the 2-dimension plane, and this guy here would be more like that. Okay, and that's what you'd get. And this guy is obviously going behind the screen. This guy is coming out, and this guy is right in the middle, just like a tripod. Okay, let's go ahead and do C. C is quite easy. It looks like this, really. P with an H, and an H, and you've got your lone pair right there, because phosphorus, as you know, has 5 valence electrons. Okay. All right, so that's that. And what do we have here? We have an sp3 as well. A lone pair plus 3 hydrogens makes for 4. That gives us an sp3. If we were to do it in this format, you would have A, X, 3, and your phosphorus would go ahead and give you 1 lone pair, E1. Okay, and again, 3 and 1 is 4, sp3. Okay, last guy right here. I'm not going to draw this entire thing out because there's no need to. But they want us to go off with sulfur. Okay, that's our centralized atom. So really, with the sulfur, you're going to have 1, 2, 3, 4, because sulfur. Let me see. Sulfur is in group 6. Okay, so 1, 2, 3, 4, 5, 6. Whoops. There we go. That's what it's going to look like. Okay, and you've got a CH2 over here, and then this, of course, carries on, blah, 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 but we're just going to worry about this guy up here. So this here, you've got your 2 lone pairs, you've got 1, 2, 3, 4, 5, 6, Okay, that works out there. And yeah, that looks good. And we've got SP3 again. 1, 2, 3, and 4. And you could also write it out as A, X2, E2. And again, 2 plus 2 is 4, SP3. Okay, so this is pretty much what they asked for, and hopefully that made some sense for you guys. See you in the next one.